Hey, it's me, Steve. It's July 11th, 2017. Time is 12:29. It is 86 degrees Fahrenheit out, and it's Geo-Rant time. This is actually going to be a supplemental Geo-Rant to my Geo-Files series. This is going to be supplemental to episodes 3 and 4, which have already been recorded. 3 is up. It's the video right below this one. If you have your videos listed chronologically, I'll link it anyway. But I was going to add this to the second part. I've recorded the second part, but I haven't assembled it into a video yet. But I decided to do this separately because I'm trying to keep my Geo-Files episodes to less than an hour, somewhere between 30 and 60 minutes. So this is supplemental to that, and I'm going to talk about streams. First, I'm going to show you two diagrams. I'm going to show you this one first. This is a map view. So like you're looking down of a hypothetical river, stream, it doesn't matter. I'm showing you the parts of that stream. This here would be the baseline, and I talk about most of these in my Geo-Files episodes, so I'm not going to go into too much detail here. But this is your baseline, which could be the ocean, a sea, or a lake. In this case, I think we're going to make it a lake because of the second one. These orange highlights are where the river velocity is at its greatest. If you'll notice, it's on the edges of meanders. Rivers will meander naturally once they approach their baseline. But you'll see there's no orange here by this meander. That's because this one is forming a cutoff. The river channel was going here, but now it's trying to go this way. And eventually, if it chooses this path, this will become cut off and will form an oxbow lake like we have over here. You have a natural levee here, which is part of the cut bank. Cut bank is where rivers are actively eroding. When you have a well-developed meandering stream like this, your erosion, you're not going to down cut anymore. You're not going to erode down. You're going to erode laterally like this. But in this part up here, it hasn't hit the baseline yet, so it's still mostly down cutting, even though you have some slight meandering, which is most likely due to the geology or the amount of rocks there or whatever. But you have, where this big dash line is, this is where this river's direct influence is. This is where the meanders are going to be constrained to. This is where the flooding is going to be constrained to. That's why it says floodplain here. The river's influence will not extend past this dash line. It's all within here. Past and present. Rivers actually are not very long-lived things. Most only last a couple million years. Some well-developed ones like the Mississippi, the Amazon, Colorado, and the Nile are probably on the order of at least 5 million years old. The Mississippi could probably even be that initial river, not as it's seen today. We know it's changed significantly, but a proto-Mississippi is probably probably extends back to near the time of the dinosaurs, actually probably just after, probably around 50 million years ago. But okay, so these are the plains. So, and you know, like I said, this is your river valley, so that's where your river will stay constrained. Here's a tributary. When you see a dash line like this on a topo map, that means that the stream is intermittent. That means it does not flow all year round. But this is just to show you how a tributary connects to it and its confluence. And these red lines are topo lines. It doesn't matter for how far apart they are, you know, 10 feet, 10 meters, 30 feet, it doesn't matter. This is just for illustration purposes. Now, what if we start trying to geologically map this and we notice something? Okay, this is how you can go back in time. We notice that there's an old river channel that this river used to occupy within its valley when the baseline was higher. Now this is your old delta. Anything in red represents the ancient channel that no longer exists, okay? So you have a higher baseline. When this was your delta, your channel went like this, okay? So once that lake level dropped, the river in parts would have started down cutting again, but it wouldn't have dropped a lot in this case. So it'd still maintain a good meander pattern, but it also would have left terraces higher up deposits that would have been old point bars, because where rivers cut actively, that becomes a cut bank. Where they are not, on the opposite side, where stream velocity is lower, you get point bars, like in between the meanders. Okay, so those terraces would have been old point bars, and they're higher in elevation than the present river, which is still the blue river flowing through here. The black dotted line is the ancient river course. So that's one indication that this river's baseline was higher. Another one would be, well, right here, these are delta deposits, which would be mostly alternating sands of low, of low cross beds with silts and clays. And you would look for evidence of a shoreline here, and if you find it, then you know your lake level used to be higher. But this is just to illustrate to you how streams change through time. So this would have been an ancient stream pattern, the black dotted line. But notice it's still confined to the valley. And this would be your modern one with the names of each of the features. Now these names are not geologic features, they're geomorphic features. They're landscape features. But we use them in geology, and we're talking about the sediments. So anyway, that is it. I hope that wasn't too long, and I hope you learned something.